Hello, welcome back to Blender Sushi Live Noding. In this episode, we're gonna be using animation nodes and we're gonna revisit the animations concept study. So procedural animations tend to be kind of scary concept, but we're gonna learn it from, I think, the most basic one again. So the idea here is that we want to control the scale of any objects, in this case, the monkey head. And we have two monkey head and we have two node tree set up here. I can probably delete one of them to make it simple. So one monkey head is no longer self-animating. So delete that. Okay, so we have just this guy right here. It starts from nothing and then it's scaling up until a certain position. There's a little bit of animations, what do you call it? Interpolations there. So it looks quite nice. And it stops at that point, and then it's kind of hold that point, hold that keyframe for a while, and then it's gonna scale down to 0 and disappear. And it's gonna repeat it over and over again. So there's actually a lot of concept there that you might want to understand. So if you are doing a animation like that, you probably gonna be doing a keyframing, like being shown here in this graph. This is a you can imagine it like a animation graph. And so let me draw it again. Basically, you start with scaling at 0, and then you will either linearly or change the curve. And it's interpolating and animating from this point to that point, and it's gonna keep hold. So there's basically at least like three different animations happening here, and at least you have like 4 keyframe. So animation itself is always a value that's changing over time. This is a value, and in this case we are really looking at the value of the scale. So we need 4 keyframe, but there's 3 blocks of animations or 3 action happening: scaling up, hold that scale, and then scale down. So there's 3 types. That's why we have these 3 things. Animate Matrix. Animation nodes actually already provide something else called offset. So this offset is actually, this is also some type of kind of like a bundle of what I'm creating here. This is like much simpler, but for some people it can be much more complex. Basically, you can offset between 2 positions using this guy right here with a fall off. Fall off is like a delay or like the offset of time. Yeah, but we're gonna tackle the offset matrix for later. For now, it's just animate matrix. So based on this diagram here, so we have 3 actions, right? 1, 2, 3. Let's say for the first one, we want it to be 25 frames, the durations, and the second one, it's keeping the hold for 50 frames, and the last one, 25 frames. So that's actually what's gonna happen with the animations if I test it. So Suzanne, from 0 to around 25, it's gonna scale up, and then it's gonna hold it for 50 frame, and then it scale down for 25 frame. So that's exactly what's going on here. The time itself is currently that there's something happening with the time as well. It is actually looping, and it's multiplying, and it's subtracting. Let me kind of reset it to normal. So now it's kind of normal thing. This is what is supposed to happen: 0 to 25, animating up with a sum of these funky interpolations there, ease in, ease out, and then hold it for 50 frames, and then animate down for the durations of 100, 25 times 50 times 25. It's gonna complete the animations. But suddenly Suzanne is animating again. and goes back off again. Because of this, there is a loop. There's a loop happenings, and this is happening every 150 frames. Okay, so let's break this down a little bit more. We start actually with procedural nodes. We can normally start from the last node here. We know that there's a Suzanne as an object input, goes into object matrix output, and object matrix output is expecting some kind of matrix data, which is the transform of the objects. And in this case, we are only dealing with the scaling. We don't animate anything else. Translations and rotations is all 0, but the scaling is actually animating. So there are actually 4 keyframes here. 1, 2, 3, 4. And the one that's changing is the scale. Scale from scale 0 to scale 1, and then from scale 1 to scale 1, and then back to 0. So 4 keyframes. Just like when you are keyframing for animations, you will need a 4 keyframe state. And then since this is kind of a procedural, we are using nodes. This is actually these 7 nodes represents the whole animations. When it's keeping the hold position is the linear, but when it's scaling up and scaling down, there's a slight interpolation there, is in, is out. So that's why we get this monkey head animations. So yeah, and we are chaining this node. By chaining these nodes, it's actually this node is doing some clever things in the back. It's really combining all these keyframe animations into a single kind of single action. And remember that all this is really all we really care at the end is the final matrix. And there are a lot of other animate nodes. So Animate Matrix is the one that we are using now. There's Animate just the vector, float, color, Euler, or quaternion for the rotations. So you can animate any of this type of value similarly, just like this. Those alone are really powerful. So like I said, the whole thing creates a single action, right? And we can apply it to anything. We can have like a torus, for example, a donut. We just replace the objects with the donut. Now the donut is in the center because the position, all the position at 0, 0, 0. You can change that, of course. Suzanne is now no longer in control, but the donut is now scaling up, scaling down. So these parts should be pretty clear. You can play around with the durations, etc. We can actually change the duration here. Like if we want to hold the position for 200 frames, we can just change the number there. So now the total animation is going to be 250. This one, the loop, will need to be changed as well. There you go. The animation's now happening. If you want to have like a pause for the 50 frame, set it up to 300. So for every 250 frame of actions, there's a 50 frame of nothing, and then the action's gonna happen over and over again. So this animation part is clear, and this transform part is also pretty clear. What's going on with the time itself? Here we have a time, just a normal time, but in terms of procedurality, since everything is kind of happening like kind of like a driver, like a self-animating, time, a concept of time is no longer like a static time. Like whatever happening in a timeline, we can actually change. We can process it, we can change it using our own mechanism. So the time itself is really something that you can animate separately. You can have a lot of these action blocks, and then you animate the time like differently, and you can scrub on it. It's gonna happen automatically. But you can also, of course, use the time from based on this time frame. If we just plug it in, then it's gonna follow that. If I'm just plugging the time will never come back. It just the animation is gonna happen and it's gonna stop. Here I'm starting to add like 3 more nodes. The subtract itself, this one is actually becoming like an offset. So subtract or add can be some kind of offset. I'm actually using subtract because if I want to offset it by 50 frames, now the animation is not going to happen until it hits 50 frames, and then animation happens. I can delay it like 100 frames, and for 100 frames nothing will happen. 100 frames nothing will happen until I goes into frame 100 and animations will happen, and it's gonna happen once and it's gonna disappear. Let's make this smaller, so it's the total value is 150 frames. So it's gonna happen once because we only have a single time frame here, but we can add the loop. So if we add a loop, it's gonna happen over and over again. So now the time is repeating. Just for this setup, for this mechanism, the times will repeat for the torus, kind of like Groundhog Days. So it's gonna continue over and over, never stop. There is no variations. The action is gonna happen over and over again. But once you start to understand procedurality and nodes, you can add variations to all these, especially the durations. If you change the durations for every loop, then you're gonna have like a varying animations. Okay, let's continue on. So we get a loop covered, we get an offset covered either using add or subtract, and there's a math here. This is for the time, of course. You can speed up the time by 2, so now the animation is gonna happen twice faster. You can slow it down, multiply it by 0.5. So there you go. This is like, I think, as simple as I can to explain procedural animations using animation nodes add-on in Blender. So the whole procedure, I write it down as text as well here. So basically, we want to delay or offset the animation by 50 frames. So we are setting up the action, the animations, animate the scale for 25, and then hold the animation for 100 or whatever value, and then scale down. This one scale down, first one scale up. So 3. For this action, we actually need a 4 keyframe, and this is the whole animation here, animation actions. And once you have this, you're done. Just pass the value back into the objects. Sometimes it's really interesting because we are really creating some kind of mechanism to control a value of something. In this case, we are controlling the transform of the objects. The objects can be anything. Let's go back to Suzanne. Let's say you want to have this whole setup and then you want to duplicate it. Let me save this first. You just need to create 2, or you can create loop. But in this case, I'm just gonna duplicate the whole thing. Gonna have another Suzanne. Both gonna animate. If I select Suzanne number 2, both animate at the same position because we need to kind of change the position of the other Suzanne. So I'm gonna translate it 5. Oops, no, not in the, just 5 in the X, or 2 should be enough. So I changed the translations. Now Suzanne gonna be at different position, maybe 3. Okay, Suzanne at 2 different positions. If I want to delay the other one by 0, so first Suzanne, we're gonna animate first, and then the second Suzanne, and then disappear and disappear. So that's easy. You can take care of it, and you can have like multiple of just duplicate the nodes over and over if you have many objects. But soon enough, you want to use a loop. If you have 100 objects, you don't want to duplicate the whole thing over and over again. You want a single setup like this but will happen. It's gonna loop for every object with some kind of delay. That will be, I will try to explain that on the next live noding, but this is pretty much it, I guess. For this is pretty clear. So this Suzanne, you can actually adjust all these animations. Like for example, you want Suzanne to kind of go up like 2 unit. You can change that. You can change that on the fly. So now Suzanne is kind of animating up while it's changing the positions, and it goes down and goes back to 0, 0, 0. See, there's a lot you can do even just with this simple setup, because we are basically dealing with 4 keyframes for different transform, and we are chaining it using Animate Matrix. So these 3 actions become a single block of actions. You can, of course, you can do more. You can animate in many different ways, you know, like have a lot of different actions. But yeah, we are only dealing with transform. Of course, at some point you might be just want to use animate vector, but above this you might animate using bones, or you animate other kind of value that's a little bit more complex. Ideally, I think maybe at some point animation nodes will have some kind of ways to control actions, just like NLA, but non-linear animations. This is like an NLA, but this is like maybe something in the future. You just plug in an object's action, and the action, how do you want to, the speed of the animations, you want to kind of move back and forth, things like that. I guess that's gonna be for the future, but this is as simple as I can explain about this Animate Matrix. Do have a look at the offset animation as well on the offset matrix, but this is, since this is like working for multiple value, even though this, once you understand the nodes, it's become really powerful, but you are dealing with multiple values here, and then you also have like control over many things. Then you can add multiple value here as well. It gets a little bit more complex. That's why I go back and try to explain this again. So hopefully this is very clear, and this is I'm making this video so that everyone can learn, and also if I forgot in the future, I can always come back to this video. And yeah, I think this is as clear as possible with procedural animations. Hopefully this is useful. So let me know what you think. If you want to add something, give me your feedbacks in the comments, or if you have like a different ideas or how to understand this, make a video, put it on YouTube, and we can share our knowledge. So thanks again for tuning in, and I'll see you next time. Bye.